Now I want to talk about what an isotope is. So an ion is a different number of protons and electrons. An isotope is when an atom has a different number of neutrons compared to protons. So let's use carbon as our example. So carbon. A lot of times carbon will be written with its atomic mass at the top. So we're going to write carbon 12 up here, and I'll explain what that means. So if we look here at the periodic table, we'll see carbon over here. Carbon has an atomic number of 6. So that means carbon should have 6 protons, 6 neutrons, and 6 electrons. So the way that we find atomic mass of an atom is by adding the protons and the neutrons. So if you take protons and you add the neutrons, you're going to get the atomic mass. And that is, like it sounds, it's how much that atom weighs. Now we don't take into consideration electrons because electrons are so small that their weight is minuscule in comparison to the protons and neutrons. And so when we write carbon, you see here that carbon has the atomic number of 6, but we would never write C6. We don't have to write the atomic number because we have a periodic table for that. We always know that carbon has 6 protons. We know its atomic number is always 6, that never changes. But the atomic mass does change. So when we write an element, we write the atomic mass above it. So C12, so carbon 12. Carbon 12 tells me that it has 6 protons and 6 neutrons. That's where we get its atomic mass at 12. There is another carbon that is popular, carbon 14. And you've probably heard of carbon 14 with carbon 14 dating. It is used a lot of times to date organic matter. And so the difference between carbon 12 and carbon 14 is that carbon 14 is an isotope. How do we know this? If you take the atomic mass and you subtract the amount of protons that the atom should have. So carbon 14 minus 6 is going to equal 8. You now know that this carbon has 8 neutrons, which means it has a different number of neutrons than protons, which means it is an isotope. And so the same thing if we were to have carbon 13, which is sometimes found in nature. So carbon 13, you subtract that from its protons that it should have, and this is going to give you 7. And so you know that carbon 13 has 7 neutrons. And this is how all isotopes work. And so let's look at another example. And so if we were to look at, let's look at nitrogen. Okay, so nitrogen. If we look at nitrogen on the periodic table over here, we can see that it has the atomic number of 7. And so if I told you that I had nitrogen 15 and I needed you to tell me if it's an isotope or not, and I want you to tell me how many protons, neutrons, and electrons it has. And so I have not told you if it's an ion or not, so you'll assume that its electrons are just the same as its protons. So this nitrogen, okay, has the mass of 15, and so looking at the periodic table, its atomic number is 7, so 7 protons, and 7 minus 15 is going to give you 8. And so we can now say that this nitrogen atom has 7 protons. Again, how do we know the protons? Looking back here at the periodic table, it has an atomic number of 7, which means it'll always have 7 protons. We now know that it has 8 neutrons. And because I didn't say whether it has a charge or not, we are going to assume that it also has its 7 electrons. And remember, isotopes do not give an atom a charge. The isotope, the fact that it has more or less neutrons than protons is not going to affect whether it's a positive or negative atom. That is only going to happen with ions due to electrons. And so this is affecting the nucleus of the atom, because remember, in the nucleus is where you have the protons and the neutrons. And so this is what an isotope is.